This is Sharma solution, class 12, chapter 6, Determinants VSAQ, very short answer questions. If A is a singular matrix, then write the value of determinant of A. So A is a singular matrix that means that the determinant is a 0. The value of the determinant of the matrix will be 0 if A is a singular matrix. So the answer is straightforward. The determinant of A is 0. For what value of x the following matrix is singular? So as we just saw, that singular matrix means determinant is 0. So how to find the determinant? This is 2 by 2 matrix. So we take this 5 minus x multiplied by 4 minus 2 into x plus 1. That is 5 minus x into 4 minus twice of x plus 1. So this is equal to 0. So this is singular. So you get 5 4 is 20 minus 4x minus 2x minus 2 equals 0. So you get minus 6x, 20 minus 2 is 18, plus 18 equals 0. So 6x equals 18 basically. So minus minus gets cancelled, x is 3. So the answer is x equals 3. So this is how you are going to write. Write the value of the determinant. Now this determinant, what is the value? The property, one of the property we are going to use. For example, these are 3 rows. Row 1, row 2, row 3. Now you see row 1 and row 2. If in the second row, if you take x common, what do you get? 2, 3, 4 in the second row. So the first row and second row become exactly equal. That means when we have x outside, we take x outside, then it will be 2, 3, 4, 2, 3, 4, 5, 6, 8. That means first and second rows are exactly similar. And we know when the 2 rows and 2 columns are similar, the determinant will be 0. So this taking out x, so this is going to be 0. State whether the matrix, this is singular or non-singular. So 2 multiplied by 4 minus 3 multiplied by 6. So we have 4 to the 8 minus 18 equals negative 10. So this negative 10 is a value that is not 0. Singular means it has to be 0. The determinant has to be 0. So the given matrix is a non-singular matrix. Find the value of the determinant. Now the straightforward method will be 4200 multiplied by 4203 minus 4205 into 4201. But doing this will take a lot of time because this is a very short answer question. That means we have to apply certain property to make the value or the computation easier. How to do this? And this kind of questions are coming number of times in the later discussion. So this is column 1, column 2. What we can do is we can either do C1 minus C2 or we can do C2 minus C1. So we have 4200 minus 4201. That is column 2 minus column 1. I don't want to do column 1 minus column 2 because that will be negative value. Same thing will come, but it will be negative. So column 2 will change to column 2 minus column 1. So 4201 minus 4200 is 1. 4203 minus 4202 is 1. Now you can apply the 4200 into 1 minus 4202. That is going to be negative 2. Find the value of the determinant. Now same thing what we have just discussed. The straightforward way is to open it using any of the row or column. But here we will follow the same strategy and the logic which we just saw. That is, we will first make this easier. And the result will be, for this particular example, the result will be quite easier. So column 2 will change to column 2 minus column 1. Column 3 will change to column 3 minus column 1. So column 2 will change to column 2 minus column 1. Column 3 will change to column 3 minus column 1. So what do you get? 101, 4, 107 this will be. So 102 minus 101 is 1, 104 minus 104 is 1, 108 minus 107 is 1. Now C3 will change to C3 minus C1, 103 minus 102 is 1. Or you can do C3 minus C1 rather than doing C2. So this will be 2, 109 minus 107 is 2. Now in the third column we will take 2 common. So when you take 2 common, let me just show it here also rather than writing whole of the determinant. So this will become 1 when we taken 1 common. So column 2 and column 3 are exactly similar. And when we know when 2 columns and 2 rows are similar, that means the determinant has to be 0. That is how in this question the determinant is 0. Write the value of the determinant. So we'll apply the property here. The question which we have already done, we generally do the row 1 plus row 2 plus row 3 or column 1 plus column 2 plus column 3. So if we do column 1 plus column 2 plus column 3, we will get A plus B plus C plus 1. In all of the first column we will get A plus B plus C plus 1. Now we can take A plus B plus C plus 1 outside. You will get 1 1 1 1 1 1 is the column 1 and column 2, that will be 0. So this is the one way. So rather than adding 1 means this all the 3 columns, if we add column 1 and column 3, that also will solve our purpose. Same thing. So we'll add column 1 and column 3 also. We are just adding column 1 and column 3. So it will be A plus B plus C. A plus B plus C, that is the first and then third one is C plus A plus B. A plus B plus C it will be. Now we have 1 1 1. Here we have B plus C, C plus A and A plus B. Okay, now we can take A plus B plus C common from the first column. So when we take this A plus B plus C, this taking common, you will get 1 here, 1 here and 1 here. So this 3 column, in these 3 column, 2 columns are same. So when column 2 and column 1 and column 2 are same, that means the determinant will be 0. 2 rows, 2 column equal, the determinant is going to be 0. Okay. As I said, you can also add C1, C2, C3, but more sophistication is the C different 2 columns. Now A is this, B is this. Find the value of determinant A plus determinant B. So 0 into 1 minus I into I square. Here 0 into 0 minus 1 into 1. So here you get 0 minus I square is minus 1. I squared is negative 1. So I'll write negative 1 here. Minus minus is going to be plus. So plus 1 here. Okay. Now here you get 0 minus 1, that is going to be negative 1. Negative 1. Okay. So 1 and minus 1 and negative 1. So we are going to add them. 1 and negative 1, when we add, it is going to be 0. Now this is A, this is B. Now if you see the question properly, A determinant, B determinant and AB determinant. These are 3 things which we have to do it. Right. So what we'll do, we will multiply A into B. Then we will take the determinant. That is 1, 3, 2 minus 1 I am taking. This is A. And now I am taking this as B. 1 minus 1, 0, 0. So first we will multiply it. This row with this column. So what we'll get here? Let me just take it this one. So 1 into 1 plus 2 into minus 1. So you get 2 into minus 1. So you can just take it as negative also, 2 into 1. Okay, first row and second column. So 1 into 0, 2 into 0, that is going to be 0 only. Now second row and first column. 3 multiplied by 1, 3 multiplied by 1 and minus 1 into minus 1. So it will be plus 1 into 1, 1 it will be. Now the second row with the second column. So 3 into 0 is 0, minus 1 into 0 is 0, 0 you get. So 1 minus 2 this will be, it is negative 1. 3 plus 1 is 4, 0, 0 you will get. Okay, now when we have a whole row or a column as 0, the determinant will be 0. You don't have to do anything, just this is a property. If any of the row or the column is 0, the determinant is 0. So minus 1 into 0 minus 4 into 0. So this is 0, this is 0, you're going to get the answer as 0. Okay. Now we'll apply the same thing here. First you can directly do it, but multiplying 4 numbers with 4 number will take some time. So the best way is to make it easier. So we'll change the column 2 with column 2 minus column 1. So first column we are writing like that only, 4, 7, 8, 5 and 4, 7, 8, 9. Now we'll do column 2 minus column 1. So 4, 7, 8, 7 minus 4, 7, 8, 5. Column 2 we are changing to column 2 minus column 1. 4, 7, 8, 7 minus 4, 7, 8, 5. That is going to be 0. 4, 7, 9, 1 minus 4, 7, 8, 9 is going to be 2 only. So now we take 2 common. So when we take 2 common, you get 1 inside. Now you can directly do 4, 7, 8, 5 into 1 minus 4, 7, 8, 9 into 1, and that is going to be this 4, 7, 8, 5 minus 4, 7, 8, 9. It is going to be negative 4. 2 into negative 4 is negative 8. This is your answer. Minus 8 will be the answer. But this is all the steps you have to follow, okay? I'm just giving you a logic how to do this. But in exam, you have to follow all this procedure. This is omega, this is not W. If omega is an imaginary cube root of unity, find the value of. So what we can do here is, we can either, there are certain property, that is 1 plus omega square is equal to 0 and omega cube is equal to 1. We don't have to use the second property, but 1 plus omega square equals 0. So what we'll do, column 1 plus column 2 plus column 3 will do, or row 1 plus row 2 plus row 3, whichever you want. So row 1 we are changing to row 1 plus row 2 plus row 3. Okay. So let us add the rows here, row 1, row 2, row 3. There can be different ways, column adding and row adding. So I'm adding row. The solution I've showed you is using the column adding. So I'm adding the row 1 plus omega square. This second row will also be added, 1 plus omega square. 1 plus omega square, third row. What we will get, omega square 1, omega square 1 omega, and then the 1 plus omega square is 0. So if you take this outside, rather than taking it, it's a same thing, because the 1 plus omega square is 0. So we have whole of the row, one row, first row is 0. And as I said we discussed earlier, if the whole row is 0 or whole column is 0, that means the determinant is going to be 0. Now A is this and B is this. Now here I was talking about, because this type of question we have, I think 9th question was there. So what we'll do here is, the question is saying, if A and B are square matrices of the same order, then if AB determinant, A multiplied by D determinant is equal to determinant of A multiplied by determinant of B. That is, so A, B determinant. So what we'll do here is, we'll try to find out the determinant of A, we'll find out the determinant of B, we multiply them, and that is the determinant of A and B multiplied. Right? Okay. So here we'll do the A determinant, that is 1 minus 1, 1 into minus 1 into 2 into 3. Then B is 1 into minus 2 minus 4 into minus 3 into minus 4. So it is minus 2 plus 12 is 10. Now minus 7 and 10 has come as the determinant of A and determinant of B respectively. So we will do what? We will multiply these two. That is, determinant of AB is determinant of A and determinant of B. And that is going to be minus 7 into minus 10, minus 7 into 10. And that is going to be negative 70. Okay. Now 13th question is, if A equals Aij is a 3 by 3 diagonal matrix such that A11 equals 1, A22 equals 2 and A33 equals 3, Then find the determinant of A. So diagonal matrix, that means the values will only be in the diagonal, other values will be 0. And since the diagonal matrix 3 by 3, the values are given, that is A11, A22, A33 is given. So 1 is the A11 is 1, A22 is 2, A33 is 3. 0, 0, 3 it is. Okay. Now, when this in the diagonal matrix, we have to find out the determinant. So there are two ways you can do. Either you open using any row or any column, 2 zeros will be there because this is a diagonal matrix. But the best way is the property says that you just have to multiply the value of the different diagonal elements. That is 1 into 2 into 3, because 1 and 2, 3 are the diagonal elements. So you get 6 as the value. If A equals Aij is a 3 by 3 scalar matrix such that A11 equals 2, then write the value of determinant of A. So scalar matrix is just a diagonal identity matrix multiplied by the scalar value, and that scalar value will be in position of 1, which was, if the diagonal matrix is unit matrix, 1 will be there. So that scalar will take the place of the places of 1. So this is 1 0 0 0 1 0 0 0 1. So if this is 2, A11 is 2, that means the scalar value which is been multiplied to the identity matrix is actually 2. So as we just seen in the previous question, it will be multiplication of diagonal element 2 into 2 into 2, that is going to be 8. Right? I hope you got the idea. Or you can do what? You can open it using any row or column. That you can do. Just use any row or column and you just open it. It is going to become, the value will come as 8. Because examiner would love if you write like this and open this rather than writing that because you have to write this property if you are doing it using just multiplication of the diagonal element, and that is the property we have already seen while we were discussing the theory. Okay. If I3 denotes identity matrix of order 3 by 3, write the value of its determinant. So I3 is the 3 by 3 identity matrix, that is the A11, A22, A33, or you can say Aij, where I equals to j. All these values will be 1. So when you want to find out the determinant, it's simply multiplying the values of the diagonal values. So this is I3, that is 1 0 0 0 1 0 0 0 1. So Aij, that is I equals j, all this value will be 1. And the final determinant will be 1 into 1 into 1, that is going to be 1. Right? So, or you can open it using any row and column. Essentially this 1 is going to come. Either way you do it. Use the property, because if I multiply this, if I just open it using, say, first row, second, third value will not be there. First row 1 into 1 minus 0 into 0, that is going to be 1 only. Okay, this question we are going to take in the next discussion. And then thank you so much. Take care of yourself.